Hello everyone, welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a piston head for static structural analysis. We will start by double clicking on static structural. Next, I'll go to engineering data, engineering data sources. There are various materials that are used for the piston head. One of them is aluminum alloy. So I'll go to general materials and select aluminum alloy. I'll go back to project and update project. Also, I'll go to engineering data and here I'm going to add another material. As you can see here, nickel chrome alloy is another material which is used. So here various properties have been given. I will enter these properties as a material here. So I'll just write the material as nickel chrome alloy. The first property that I want to insert is the density. You can see here the minimum value is 7.75 and the maximum value is 8.65. So I will take an average value of 8. The unit is gram per centimeter cube. Next I will insert isotropic elasticity. So I have to give the value of Young's modulus and Poisson's ratio. So you can see here Poisson's ratio is from 0.26 to 0.325. So I'll take a rough value as 0.28, and also I have to insert the Young's modulus. So Young's modulus is from 150 to 245. So let me give a value as 180 E9. This is 180 gigapascal. Now apart from this, I will also give the tensile yield strength. It is between 330 to 2300 megapascal. So I will give a value in megapascal. Say it is 2100. So once the values have been entered, I'll go back to project and update project. Next, I'll go to geometry and right click. I'll import geometry. Next, I'll go to model and double click on it. I'll first go to geometry and I'm going to insert the first material as aluminum alloy. I'll go to meshing and I'll change the sizing to fine and update. Next, I'll go to static structural and I'm going to first insert fixed support on this face and this one too. Apply. As we are aware that a piston head is going to be subjected to pressure, so on this face I am going to apply pressure. The maximum value of pressure that is inserted on the piston head varies from application to application. Now you can give a rough value of 50 to 100 bars. So that will be roughly around 5 to 10 megapascal. So I am giving the higher value of 10 megapascal. If you want, you can change this normal to components, and along the Z axis you can give a value of -10. So this way it will be a different way of giving the value. So once these two values are given, I'm going to go to solution and I'm going to insert deformation total. I will insert strain and also I want to see the stress over the body. I will go to tools and insert stress tool. Also, I will go to tools and insert fatigue tool. Here, I am going to insert the mean stress theory as Goodman theory. I will right click and insert live. Next, I'll go to solution and solve. So you can see here, this is the total deformation over the body. The maximum value is 0.4454 mm, and this is the place where this is the crown of the piston, where you can see the value of deformation is maximum. Also inside you can see the deformation value is going to be maximum, and on the other surfaces you can just check from here what is the value of deformation. I will animate and see the result. Next is the value of strain. You can see here the various values of strain over the body. The maximum value is 0.00756. Next is the value of equivalent stress. Maximum stress acting on this body is 535 megapascal. So you can see where the value of stress is more. You can just click on max min to figure out where the value is more and where it is minimum. Alternatively, you can just click on it once again so that it disappears. You can come and click on this. You can just select on this option and click on no wireframe, such that you can just see the object without the meshes that are applied on it. And if you want to see the elements, just click on show elements. Next is stress tool. You can see what is the safety factor for this body. Your body is safe in most of the zones except for the values where it is very less. The minimum value is 0.522 and the maximum value is 15. So that's how you can see, and rest of the values can be seen here. So I'll just click on this. The rest of the values appear. Also, since you have used the material as aluminium alloy, hence you are able to see the life of this object. The maximum value is 1 into 10 raised to 8 cycles. So this is one thing. Also, you can right click over here and insert damage. Just go back to solution and solve once again, such that you can see the maximum life for which this body is designed. It is 1 into 10 raised to 9 cycles, but it is only going to work for 1 into 10 raised to 8 cycles. But again, if you see, the minimum value is 0. So that is for these zones where it is red in color. Now this is aluminium alloy for which we have figured out the values. If you want, you can change the material. So I'll just go back to assignment and I'll change the material to nickel chrome, and I'll solve the result once again, but this time I may not get the value of fatigue tool. So I will solve and show you. So since I've not got this value, just right click and delete it. Go back to solution and solve once again. You'll get the answers. That's because for calculating fatigue, there are certain more data that you have to give in the tabular form, which I've not given here. So I'm not getting that value for the material that I have assigned. But for aluminium alloy, it is available, so you can get the fatigue for it. And aluminium alloy is anyways the most common material which is used for piston head. But this is another type of material which can be used such that the life of the piston head can be improved. So now you can see the total deformation is 0.177, which has reduced. You can animate and check the result. Next is equivalent elastic strain. This value is 0.003. You can see the equivalent stress over the body is 543.2 megapascal. And the safety factor now has improved. Most of the body is blue in color, except in few cases you can see the value is little green, that is 10, and here you can see it is orangish, that is 1. So obviously with the change in material, you can see that the piston head has become more safer to use, and it is going to be performing better, and obviously the life is also going to be more for this piston head. So with this I end the session. I hope you have understood how to analyze the piston head for static structural analysis using different materials for it. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.